A linear equation makes up a straight line on these coordinates when graphing. First we'll start with the standard form x plus by equals c. A, b, and c are coefficients, x and y variables or points on the graph they're plotted. For example, 3x plus y equals 3. Do you know how to solve it? First off, for y, for putting 0 for x. 3 times 0 is 0, so y equals 3. The intercept point is 0, 3. On 2, step 2 is solving. Solve for x, for putting 0 for y. X equals 1, 1, 0 is your next intercept place. You graph your 2 points and draw a straight line, and your line's looking great. Equation, standard form of the equation. To linearly draw a line straight when you're graphing. Ax plus by equals c. Equation, standard form of the equation. To linearly draw a line straight when you're graphing. Ax plus by equals c.
Well, welcome back, Algebra 1 students. We're here looking at 3.4, and this is called Graphing Linear Equations in Standard Form. So just like that little song was showing you, ax plus by equals c is the standard form of a linear equation. So we have two variables, so in two variables here, where a, b, and c are going to be numbers. And so the first thing we're going to look at actually is going to be graphing equations of horizontal vertical lines. And those are not necessarily going to be looking like this. In fact, it'll more like just be x equals a number or y equals a number. So we'll look at those in a minute. And then the main part of it, though, is using the graphing the linear equations in the standard form here using intercepts. So that's really what that little video or song was showing you. They were using intercepts to graph those, and we'll do that. All right, well, let's take a look at our cartoon for the day to get started. So this would be sheep health classes. So if sheeps had health classes, they had to look at themselves getting sheared. And this guy in the back here just passed out. All right, moving on to our first part here. All right, so this is the standard form. So there's a vocabulary word there in your notes. You can just write down what I underlined here. Standard form next to that, just of a linear equation is this, the ax plus by equals c, just like that song was talking about, where a, b, and c are real numbers, and a and b are not both 0. So if they're both 0, then that would basically take out both the x and the y as well. So they both can't be 0. You can have one of them be 0, that would be okay, but they both can't be 0. And if you do have one of them being 0, either the A or the B, then what you're going to notice is you're going to get one of these kind of things, of a horizontal or vertical line. So you can see, okay, if you just have y equals b or x equals a, and that's just using this kind of idea here. Basically, if this was, if the a was 0 here, that takes out your x, like 0 times x is now just going to be by equals c. So you're just going to see, basically, if y was 1, 1 equals c. I probably would have rather had just a letter C there, but they used letter B and A, that's okay. You're going to get a horizontal or vertical line. So if it says y equals a number, so B is just a number, like y equals 2 or something like that, you're going to see it just go straight across right there where the y is actually at 2. So on the y, where is it at 2, or where is it at this number? Just go straight across, horizontal line. If it's x equals some number, it's going to be a vertical line through it where it crosses the x-axis. So where is that number on the x? It's going to be, a is going to be whatever is here. So if a was 2 and x equals 2, well then it's going to go right through here. So these aren't very difficult to do. The only thing is just remember which one is which. That the horizontal ones are going to be the y equals the number, and the vertical ones are x equals the number. So let's go ahead and continue to look at a couple examples for that. Alright, so you don't need to write these down. Let's just go and look at them. It says graph y equals 4 and x equals -2, and we're going to do this on a coordinate plane. So you can see right here, for letter A, the y equals 4 is just going to see where 4 is on the y-axis, and it's a straight horizontal line because it's a y equals. So if it's on the y-axis, y equals 4, and you go there, if you drew a vertical line, it's going to be on the y-axis, and that's not going to be what you want there. If it's going to go right through here. 4. So straight across through 4. Basically, y is always 4. You can see it is y is 4 here. So when you come -2 for x, y is 4. And you come over here 3 for x, y is 4. So y just constantly is 4. We kind of call this one a constant function, in fact, because it is just constantly 4. It is a function, just like we were talking about before. It meets the function requirements where it passes the vertical line test. So we can call this a function. This next one, though, x equals -2 vertical line. So where x is -2, it's going right through there. And it's just x is constantly going to be -2 everywhere along this line here. Yeah, so it's -2 up here, it's -2 down here for x. The y changes, though, as you go up and down this line. But this line cannot be called a function. Now, this is actually not a function because if you use a vertical line, it is a vertical line. And so it's not going to pass the vertical line test. You're going to be touching all the points at the same time with that vertical line test. So this one is not a function, and this one is. The horizontal ones, the y equals ones, are functions, but the x equals ones are not functions. We can still graph these. It's still going to be a vertical line. We're eventually going to talk about slope at some point in coming up here, and we'll see what the slopes of these lines will be as well. All right, let's do a couple problems on your extra practice. Okay, so number 1 and number 2 on your extra practice just says graph the linear equation, y equals -3, and this one's x equals 2. So I'm going to just have you try those. Do them just like I was just showing you. See if you can draw these straight lines. One's going to be straight across horizontal, the other one's going to be up and down vertical. So go ahead and stop the video at this point, push pause, and do these two, and then play it to see if your answers are correct. Alright, so hopefully you did push the pause and you're just checking your answers now. You've completed those two. So for number 1, y equals -3. So -3 is way down here. So it's going to be right through, and it's going to be, y is constantly going to be -3. -3 is here too for y. Y is -3 as well here. So it's going to be a horizontal line going straight through right there at y equals -3. And this one says x equals 2. So on the x-axis, where is 2? It's right here. And it's constantly going to be 2. So this would be 2, 1, 2, 2, 2, 3, 2, 4. X would constantly be 2 going along that vertical line. And so it's just going to be a vertical line going straight down through there. So these can be very simple to do. You just got to remember to keep them straight and remember how to graph them just as horizontal and vertical lines. Okay, so now we need to talk about intercepts. The word intercept is just kind of where the line touches an axis. So intercept means there's a connection there. So you have your blue line on this one, and we can see where does it touch the y-axis. That's going to be called our y-intercept, where it touches the y-axis or crosses the y-axis. Where does this blue line cross the x-axis? And right there at that point down here, you can see it's called the x-intercept. And so that's what we want to see here. If we wanted to say, okay, what is the y-intercept? It's going to be whatever the number is for b. So if that was like 0, 4, then the y-intercept would be 4. Or if this was 4, 0, then the x-intercept would be 4. And the way we get these, as you can see here, is the intercepts, where it's going to cross the y-axis, x is going to be 0, and then wherever x is 0, that's going to be your y-intercept. Or when it's the x-intercept, you can see where the 0 is on the y-axis, or the y number, or the y-coordinate's going to be 0. Even that little video was kind of showing you how to do this when it was saying use the intercepts to graph it. And so basically what we want to do is to find the x-intercept, we want to plug in 0 for y into the equation. We're going to see some standard form equations right here, like ax plus by equals c. We'd want to plug in 0 right here for y. That way it cancels that out. And now you can just solve for the x, because you'll have an ax would equal c kind of equation. And then you do the same thing to find the y-intercept. You're going to plug in x equals 0. So you're just going to plug in 0 for x, and that would cancel the x term out, and then you'll be able to solve for y to find the y-intercept. Okay? So you have an input and an output. Your input, just like we've done in the past with a coordinate plane, just like if I was in, or not coordinate plane, a table of values. So for our x and y axis here, if we put in 0 for x, as you can see on this one, what I'm going to find when my output is, that's going to be my y-intercept. right here. I'll just put int for intercept. And then if I put in 0 for y, if I use that as an input that for y, what I would get out over here would be the x-intercept. The coordinate I would get would be the x-intercepts. So that's going to be an that's going to be a x and y coordinate that you'd find on the coordinate plane, just like we see here, 0b or a0. So they're using b for this right here, and they're using a for it right there. All right, let's try a couple now. Okay, here's another one. You do not need to do this one. We'll just look at this. We're going to do a couple that's just like it. It says use the intercepts to graph this equation. So here's your standard form equation. There's your ax, your by, you're equal to c, and a, b, and c are all numbers. So the first thing we need to do is find the intercepts here. So we're going to find these intercepts. They're going to find the x-intercept first. So they're going to substitute 0 for y to find the x-intercept. So 4 times 0 is going to cancel that out. And now they're just left with 3x is equal to 12. And they're going to actually solve that. X would equal 4. If you divide by 3, 12 divided by 3 is 4. So your x-intercept is 4. That's what they're showing you here. Then they're going to solve for the y-intercept. They're going to plug 0 in for x. So they'll do the same thing. And now basically you can divide both sides by 4. 12 divided by 4 is 3. And so the y-intercept is 3. So those are your x-intercepts and your y-intercepts. So now you just go to your coordinate plane. If you need to draw a coordinate plane at some point on a piece of paper, or if you have graph paper or something like that, you draw your coordinate plane. You're going to plot both of these intercepts. So your x-intercept is 4, so you come over here to 4 on the x-axis, which is 4, 0. So as an ordered pair, your x-intercept is 4, 0. The y-intercept, if you come up here to 3, you plot a point on the y-axis, and the ordered pair there is 0, 3. And that's all you need, just 2 points to be able to draw a straight line. You can now just draw a straight line through those 2 points. Notice, you're going to notice here when I click this, it's not going to just connect the dots. It's not enough to connect the dots. You have to actually have a line that's going to go through it. So you can see the line goes all the way through, and notice at the very ends, before, at the ends of this window, this is only just a little window of a coordinate plane, because it's an infinite coordinate plane. As you can see, the arrows on the x and y axis keep on going forever each direction. So you're going to put arrows on the end of your line to show that it's going to keep going up this way. It's going to keep going down the other way as well. So that's why it's a line. If you just connected the dots, we would call that a segment. And we don't want to graph just segments. We want to graph lines. So that's going to go all the way through. All right, so now as we continue on with our extra practice problems, 3 through 5 said to find the x-intercept, x and y-intercept of the graph of the linear equation. So this one does not say to graph it. That's what we're going to do on 6 and 7. It just wants us to do the first 2 steps, though, which would be to find the x-intercept and find the y-intercept. Okay, so as we do those, number 3, let's take a look at this one. As we find the x-intercept, first we're going to put in 0 for y. So this is doing the x-intercept. We're going to right here highlight it. You're going to plug in 0 for y, so you have 3x plus 4 times 0 equals 12, and then I cancel that out, because 4 times 0 is going to go away. I mean, you can write a whole nother equation here of 3x just equals 12. I usually just at this point, cross that out, and then we can see that we can just divide by 3 now from the 3x and the 12. To solve for x, I just need to divide by 3. So that's going to cancel the 3's here, leave me with x by itself. 12 divided by 3 is 4. So x equals 4, so the x-intercept is 4. And so we want to write that as an ordered pair, because it says find the x and y-intercepts. So we're going to write these as ordered pairs. That would be the coordinate of the x-intercept, 4, 0. Because we plugged in 0 for y, and we got 4 when we got x out. Now to find the y-intercept, so now we're going to plug in 0 for x. So x is equal to 0. So we're going to say 3 times 0 here, instead of 3 times x, 3 times 0, plus 4y equals 12. And so we cancel this 3 times 0 out. That's going to go away, because anything times 0 is still 0. And now you just have this equation here, 4y equals 12, and we just divide by 4. So divide each side by 4, and we get y equals 3. So our ordered pair there would be 0, 3. There's our x or our y-intercept. So these are the 2 intercepts. If we needed to graph this, we would plot these 2 points and then connect the dots, drawing our line through it. Okay, number 4, finding the x-intercept, we're going to plug in 0 for y. So again, negative x plus 4 times 0, we're replacing y with 0, is equal to 16. So that cancels it out. It's now just negative x equals 16. So if negative x is equal to 16, we could multiply both sides by a -1, divide both sides by a -1. Basically, in this situation, you can just change the sign of each side. If you multiply this by negative, it's going to be positive. If you multiply that by negative also to keep it balanced, it's negative. So just x equals negative 16. Negative x equals positive 16, then positive x equals negative 16. And so our ordered pair there is going to be negative 16 comma 0. And then for the y-intercept, we're going to plug in 0 right here for x. So negative times 0. That's what we'll show you right here. Negative times 0 is just going to still be 0. And now we just have this equation to solve for y. Just divide both sides by -4. And so that cancels those out. And y is going to equal 16 divided by -4. That's going to give us y equals -4 for our y-intercept. The ordered pair for that's going to be 0 for x and -4 for y. Alright, so I'm going to have you try number 5. Go ahead and pause the video. Try 5, see if you can find the correct x-intercept and correct y-intercept, and then play it to check your answer. Alright, so hopefully you have an answer for number 5 for both the x-intercept and y-intercept. Your x-intercept, as you plug in 0 for y, you'll just see a 5x is equal to -30, and then we just divide by 5. And so -30 divided by 5 is going to give us that number. It's -6. So x is equal to -6, and our ordered pair would be -6 comma 0. And then for the y-intercept, plug in 0 for x. So 5 times 0 here, which is going to cancel out. And now you just have this equation. Divide both sides here by -2 to solve for y. And so we'll see a -30 divided by -2 is going to give us 15. So y equals 15. That is the y-intercept. So the ordered pair is 0 for x, 15 for y. Alright, so at this point, we're going to know number 6 and 7. We need to do the same thing. Find the x-intercept, find the y-intercept, but we're going to go one step further and plot those on a graph, and then just connect the dots. Alright, so for number 6, we will find the x-intercept. We'll just find that one first. So the x-intercept will be first. So that means we're going to plug in, if we're finding the x-intercept, we need to keep the x, but get rid of y by plugging in the 0. So 12 times 0 there. So when we do 12 times 0, that's going to cancel out. So what I did over here, I just wrote down what's going to be left. So 12 times 0 is going to make this term disappear. What's left now of our equation is the -8x is equal to 24. So that's all I need to solve to find the x-intercept. Divide both sides by -8. And so x is going to equal 24 divided by -8, which is -3. That is the x-intercept. Let's go ahead and plot that on our graph. I didn't write the ordered pair. Instead, I just plotted the point of the x-intercept here. So on the x-axis, where is x equal to -3? Over here to the left, there's -2, -3, -4. So you just put it right on the x-axis. And now if we need to find the y-intercept to get a second point, because you always need at least 2 points to draw a line. And if you use the intercepts, you just can do those 2 points. So y-intercept means we're going to plug in 0 here for x, which means this first term is going to go away, so the only thing left is the 12y equaling 24. So if 12y equals 24, we solve for y by dividing by 12. 24 divided by 12 is 2. So y on this one is equal to 2. So the y-intercept is 2. So on the y-axis, we got to go, where is 2? It's right here, 2 above the origin, above 0. And so you're going to just plot a point right there. And now that we have those 2 points, we're going to not just connect the dots, we're going to draw a line all the way through. And it'd be good if you use a straight edge, like a ruler, or something like that, or maybe the side of a card, an ID card, or one of those gift cards or something, as a straight edge. And you can get a nice, neat, straight line going all the way across. And don't forget to put arrows on each end of your line to show that it keeps going each direction. Let's do number 7. I'm actually going to have you try this one on your own now. So go ahead and pause the video and find the x-intercept, plot that down the x-axis, find the y-intercept, plot that on the y-axis, and then connect the dots with your straight edge, draw a line. So go ahead and do that, number 7. So pause the video and then play it to check your answer. Alright, so hopefully you have a line drawn on your coordinate plane at this point. You showed your work for finding the x-intercept and the y-intercept. So to find the x-intercept, we're going to basically just eliminate the y here because 0 is going to be y, so we'll have a 2x is equal to 4 equation. And just divide by 2, and so x is equal to 2. So the x-intercept is 2. We put that right here on the x-axis at 2. And then to find the y-intercept, we're going to get rid of your x term here. So if you get rid of the x term, you just have y equals 4. That's what you have. And there's no solving because it's already solved at that point. Y equals 4, that's your y-intercept. There's nothing more to do to figure that out. Just got to plot your y-intercept up here at 4. So right there at 4 is going to be the y-intercept. And now you just need to take your straight edge and draw a line through those. And don't forget to put arrows on each end of your line. Now, one thing I didn't mention when we were talking about the horizontal vertical lines that I wanted to mention here, what if it was like an x equals 0? If it's x equals 0 or y equals 0, it's going to be right on top of one of these I should say x or y axis. In fact, if it was x equals 0, that's going to be, go and use our red here, that's going to be this axis. So this actual y-axis is the equation x is equal to 0. Because everywhere on this axis right here, x is 0. X is right now on this y-intercept right here, it's 0, 4, but it's 0, 3 here, it's 0, 2, 0, 1, and so on. So that's the equation x equals 0. For your x-axis, I'll put it over here on this side, it is y equals 0. So everywhere on this x-axis would be y equals 0. So if you were to have this, and it says to graph x equals 0, well, that's just drawing a line right on top of the y-axis. Or if it says graph y equals 0, that's drawing a straight line right on top of the x-axis. So I just want to make sure that you were clear on those. You might come across those two kind of special ones that are actually these axes for the x-axis and y-axis. Alright, as always, we want to have a joke of the day, so here we go. Why does a milking stool only have 3 legs? Well, it's because the cow has the udder. The cow has the udder. That's good. Alright. Gotta love my jokes of the day, though, right? Let's come on to our next one. Alright, here's our last problem, number 8. So it's like a real-life situation problem where we'll use intercepts to help us just make some assumptions on some things here. So it says the school band is selling sweatshirts and baseball caps to raise $9,000 to attend a band competition. Sweatshirts cost $25 each and baseball caps cost $10 each. The equation 25x plus 10y is equal to 9,000 models this situation, where x is the number of sweatshirts sold and y is the number of baseball caps sold. So right there, it gives you kind of something that you're going to need to know how to do, and that's to write an equation given some information. So this kind of modeled something for you that we're going to need to do soon, is writing out these equations. So if we just had the first 2 lines here, and we were just told about the raising $9,000, sweatshirts are 25 and caps are 10. So there's 2 things here. So for every sweatshirt, you pay $25. Every cap is $10. So that's why your variables are the unknowns. It's the number of sweatshirts sold for X. It's the number of caps sold for baseball caps sold for Y. And so if we wanted to buy so many sweatshirts, so many of this, we can see how much it's going to cost. But we need to figure out here that 25x plus 10y is equal to 9,000. We need it to raise up to 9,000. That's why it's going to equal 9,000 here. So number 1, letter A, I should say, find the x, or find the intercept, find and interpret the intercept, sorry. find and interpret the intercepts. So let's find those intercepts first. Just plug in x, plug in 0 for x, plug in 0 for y, just like we've done before. So 25x is equal to 9,000. So I plug in 0 for y, it's going to take out this term. 25x is just going to equal 9,000. Divide by 25. Here's where we'll find the x-intercept. X is equal to 360. So basically what that is saying is the intercept means if I give 0 for y, which means we basically have no caps sold at all. If we sell no caps, no baseball caps at all, 0 of them, that means how many sweatshirts do we have to sell in order to get 9,000? We need to sell 360 sweatshirts to equal the $9,000. So that's one way to get the $9,000 is just only in sweatshirts alone. It's going to mean we have to sell 360 of them to raise the $9,000. The other intercept for y, we're going to again put in 0 for x. So basically saying we're not going to sell any sweatshirts. So now it's just 10y equals 9,000, divide by 10. So we divide by 10. That's basically going to be, you can cancel those zeros out there, take one 0 out for the 0 below it. That's 900 over 1, which is 900. So y equals 900. We would need to sell 900 baseball caps in order to have no sweatshirts sold at all. So if nobody wanted sweatshirts, we would have to sell 900 baseball caps in order to get the 9,000. That's what those mean there. So when it says interpret, that's what you're interpreting. Now it says here, if 258 sweatshirts are sold, how many baseball caps are sold to be able to equal the $9,000? So that means that this is our x, where sweatshirts is representing the x. So if we sell 258 sweatshirts, so we plug in 258 for x, so that is our x there to plug in. So 25 times 258x, and then we write the rest of the equation, plus the 10y equal to 9,000. We then multiply the 25 times 258. So as you do that on a calculator, so we can do it on a calculator here, 25 times 258, and it's equal to 6,450. So that's 6,450 plus 10y is equal to 9,000. Okay, so now we need to get the 10y by itself on the left side of the equation. So subtract 6,450 from both sides. And I will cancel here, so we're now going to get 10y is equal to, subtracting those numbers, that's going to give us 2,550. We just need to now divide by 10 to solve for y. So when we divide by 10, we can cancel those zeros out. So we have this ends with a 0, this one ends with a 0, so 0 for 0 can cancel out. 255 now over 1 is 255. So that tells us y is equal to 255, which means there's 255 caps that were sold. 255 baseball caps. So if you sell 258 sweatshirts, you have to sell 255 baseball caps in order to equal 9,000. Now in the letter C it says graph the equation. Find two more possible solutions in the context of the problem. So this is one scenario for them to be able to raise 9,000, is if they sell 258 sweatshirts and 255 baseball caps, they would raise up the $9,000 they need. But there's obviously other combinations that we can do. So graphing it would actually show us all the other different combinations that we could do. So let's go ahead and graph it on this coordinate plane here. So make sure that I think this coordinate plane should be there for you on your notes, but if it's not, you might just have a little box here. Definitely want to put the x-axis and y-axis like this, because this is going to all be positive. This is like the first quadrant of a coordinate plane. So this would be 0, 0 right here. So if I go ahead and start to number these up here, we're going to number them like this. So put 0 here, 0, 0 for x and y, but every line up here is going to be 100. Now the y-axis, remember, is representing, y represents the number of baseball caps. And remember the y-intercept here was 900. So we need to get all the way up to at least 1,000 to see this y-intercept. So if I say every line here, every box is worth 100, that'll get me to it. For this one, I'm not going to need to go by 100s. This one I'm going to go by 50s. So each box is going to be 50. That way I can get over to 360 for this x-intercept. So now that I have everything marked out, you definitely have to always do this whenever you're going to do one of these real-life situation problems, is you need to make your own numbers for the y-axis and the x-axis to kind of coincide with the information that you have here. We need to plot this ordered pair where it would be like 360, 0, and this would be 0, 900. So that's going to cause us to make sure we don't just go 1, 2, 3, 4. That's, we need to go by 100 here to get up to 900. Alright, so now let's go ahead and plot these two intercepts. So the first one there can be the y-intercept. We can say, okay, there's 900. Y is equal to 900. So the y-intercept right there is 900. And this one's 360. So on the x-axis, 360. So there's 300, 350, 360 is just going to be a little bit to the right of this line into this box here. So we're going to have to estimate a little bit for that one. And now this one, I'm just going to connect the dots. I'm actually, since it's a real-life situation problem, I'm not going to draw a line through them. I'm going to make more of just a line segment on this one. So if you just connect the two dots, that draws your line, because all the information you want to see is just in between these 2 points. And so now this can help us figure out what it says here. Find 2 more possible solutions in the context of the problem. So let's see, what we could find here is if you go along this graph, you can kind of see maybe where is it maybe connect to something. So somewhere maybe right around in here, like that. That's kind of close to a grid mark right there where you get a nice clean point perhaps. So where would that be? That would be 300 for the y here and about 250 for the x. Now this would just be an estimate. This is not necessarily an exact thing, but you could try and say, well, if maybe if you say at this point right here, that's around 250 sweatshirts from down on the x, and that would be about 300 baseball caps. Again, it's 2 possible solutions, so this could be a possible solution. It's pretty close to it. It was definitely going to be a little bit off, I think. It's not going to be perfect. You could find another one on here. So as you kind of go along, where might be another one that you could find maybe right in here, maybe right at the 400 mark here, and 200. So maybe 200 sweatshirts, 400 baseball caps. That's another option maybe that you could use. I'm only going to just do that one. You can write the other one down if you want to as another possible one. Alright, well that concludes our lesson here on 3.4. So until I see you next time, have a great day.